welcome to Anu's classroom. So this is an on-demand video for MMPC 9. Okay, so in the Telegram channel I had asked yesterday if there are any topics which you want me to expand more on, explain more on MMPC 9. So this video is curated based on the topics that you guys had suggested in the Telegram channel. So let's get started. So the first topic which was asked was product cycle. Okay, about the product life cycle. So first I will explain about that, then we will go one by one on the other topics. Okay, so when you talk about product life cycle, there are actually when it comes to life cycle of products, there is this normal product life cycle which we talk about, plus there is the new product life cycle. Okay, both of these usually come under the block 1 concepts. Okay, the overview and the product selection, process selection, that kind of areas is where this product life cycle usually gets asked about. So when you are just talking about the product life cycle, we are talking about the life cycle of a product in the market. Okay, tada, not big surprise, right? So how is it? Just like the life cycle of a butterfly, right? It starts as a new fresh product, right? That is the introduction stage, like introduction, the life cycle of anything, right? Then what happens? Then it slowly matures, that is it grows, right? Not matures, it grows, right? And when at the time of introduction, the demand for that particular product or your service might not be that great, but as time passes, ideally it should have an upward trend, that is the volume of your sales should increase. So the product life cycle is usually a graph with with time on your horizontal axis, x-axis, and volume of sales on the y-axis, the vertical axis. So as time passes, we expect that the service or the product that we are offering should grow in volume, right? And at one point of time, a stage will be reached where you have attained your maximum capacity. That is called maturity stage. So this is not something new, right? We have already studied about product life cycle in our first semester, but still, since you guys asked, I'm explaining. Okay, and then once we are in the maturity stage, companies try to prolong this maturity stage, right, as much as possible. But at a certain time, we start seeing a decline, that no matter what you do, the demand for that particular product gets declined, right? So what companies usually do is they go for two approaches. One is to what you can say, give as much time or stretch as much as possible this maturity phase. Okay, this time gap, they try to expand it as much as possible. Some of the ways in which they do is maybe they might revamp the product a little bit, give updates, okay, or find new users for the product which is earlier not thought of, things like that, right? Like for example, Milkmaid. Okay, the first example that came to my mind was Milkmaid. So Milkmaid is a sweetener. We usually used to use it to sweeten milk payasams, kheers, and things like that, right? But when they had reached the maturity stage, in order to prolong the decline, it is still in the market, right? It is in this maturity stage. Actually, they're trying to prolong the market by how? By giving people opportunities to reinvent things that they could do with Milkmaid. Now there are a lot of cooking shows wherein it is mandatory that in any recipe they use Milkmaid, and show you how all the other ways in which you might use Milkmaid, right? So that is one example of us trying to, or the companies trying to stretch out this maturity to decline period. Okay, so that is the product life cycle. Coming to the new product life cycle, what we are talking about is the stage up till what happens before the introduction. How does a new product actually hit the market? What happens before this introduction stage is what we are talking about in the new product life cycle. So how does that happen is, first and foremost, it all starts with brainstorming, finding out what can be done to improve. So why do people go for brainstorming? Why do people go for that? Why do businesses go for that? Because they might have found a gap in the market wherein they can introduce a new product, right? They might have identified a gap in the market between the needs and the existing products, right? So how did they find this gap? Through research. So the first step in creating a new product or in a new product life cycle would always be research. It is through research, research, that we find that there is a gap where we can introduce a new product. So once we have the research, once we have the data, we start looking for ideas, right? So idea generation idea generation stage happens. So during the idea generation, people get together, we try and we think about a lot of ideas, lot of products or services that we could bring forth to bridge this or fill this purpose gap, right? Fill this particular gap. And we might have umpteen number of ideas. Now, not all those ideas are going to be equally feasible, equally attractive, or equally usable. So what we do is we subject this all the ideas that we generated through a screening process, wherein we analyze each of those ideas for its economic feasibility, business feasibility, and all market feasibility and things like that. And so all so through screening, what we do is we analyze initial screening we will do, and then after that we will analyze the remaining ideas, whichever ideas are remaining after the initial screening process. We start analyzing, and once we analyze, then even then we might have a couple of ideas. So what we do is we go for prototyping, that is the initial product development, right? We go for prototyping, product development. So we start the development phase, we go for its design, and once we have the design ready, prototypes ready, we start testing on it. And once we find that the whatever products are remaining after the testing is done, we start its construction, right? Actual production starts, right? Not in a very large scale, but yes, in a considerable scale, so that we can actually deploy or do a market level testing. So once we construct a few things, we will choose a test market or test markets, and we will start what you can say, we introduce it. So that is where the introduction stage happens. We introduce it to the market, right, for market testing. So that is called market development. And once we have favorable inputs for that particular product from the market which we use for testing, then we start commercializing it, right? Then we go for large scale production, deploying into more markets, advertisements and things like that. And to increase our market share, we start giving offers, introductory offers, sales, samples. We set up stalls to give people samples and things like that, right? For FMCG goods, we follow some particular procedure. For non-FMCG, we follow some other set of measures to push it to the growth stage, and then to the maturity stage, and prolong our maturity stage. And then, but at the end, every product will decline and will eventually die out, right? So that is the product life cycle and new product life cycle. I hope you got an overall comprehensive picture about it. So the next topic which got asked was continuous flow process and intermittent flow process. So as the name suggests itself, so this is also from the block 1, okay, product selection process selection unit. So continuous flow process, so the process flow or the production of products or services is more or less continuous in nature. It is keeping on going. Usually earlier we used to think that services and all where we could not make it continuous. It is too customized for continuous is what we used to think. But nowadays that is also getting rewritten. Think about fast food joints, right? Think about McDonald's drive-throughs. You order over here, cars are lined up, you order, you give your order at where you enter, and by the time your car reaches the exit gateway, within 2 minutes your food is ready. So how do you think it is happening? It is through continuous flow process, okay? So all the facilities and everything, all the production process, all the machines and everything is arranged with proper time and motion study principles. They take it very seriously. If you remember the time and motion study principles, they take continuous flow process, takes them very seriously into account. Everything is arranged for streamlined, super efficient processing, that continuously whatever input is there can be transferred into output. Okay, whatever input can be transferred into output in the most efficient manner. All facilities are arranged in sequence in which they are required for the output, using high speed special purpose machines, laying out the facilities to minimize the movement of materials, designing the production system so that there are no bottlenecks as well as no idle time for any of the resources. So that is why I said time and motion study, where our principles are used heavily in continuous flow processes. So what are some of the characteristics of continuous processes? We can produce high volume of goods. There is easier planning and control. Planning and control becomes very easy to maintain. There is a very linear workflow. If you might have seen, right, the drive-through is straight. So the thing is arranged straight like this. You get the order. If there are fries, there is the fry station, the chicken station. I'm talking about McD, okay? At the end, there will be the ice cream station. Why? Because the ice creams, we cannot pack it first, right? Similarly, the Coke station, all those things. And here will be the output where everything will be packed and given. And we can drive out, right? So this is the speaker. Sorry, this is the headphone area where you can speak into. the mic area, and this is the speaker area, like the output area, right, where you can collect and go. So that is what it is, a very linear workflow. Okay, linear workflow. Definitely advantages would be very low cost, right? Make the fast food joints, we get food fast for cheap rate, compared to a gourmet restaurant like Punjab Grill or things like that, or BBQ Nation, where it takes some time, right? So low cost, low operator skills, simple managerial control, but it is difficult to adapt. If any place there is a stoppage, then the entire line stops because of this linear flow. It is not parallel, it is linear. If you guys know physics, right, parallel connection, series connection. So continuous flow process is series connection. If one bulb breaks or there is a fault in one of the lines, the entire line breaks. Nobody is going to have current. So it is very, there are high chances or possibilities of stoppage of the entire line. It is very difficult to balance the line. Why? Because if there is a bottleneck, if any one station is crowded a little bit, again it would lead to all the processes till that line clogging up in the area. Okay. Workers are not much motivated. They also tend to become, more or less like machines. Worker motivation, maintaining worker morale becomes difficult, and setting up cost will be very difficult as well. Okay, so that was the continuous flow process. So we can make use of robotics, we can use CAD, CAM, CAE, flexible manufacturing and things like that to enable this continuous flow processes. So I hope you got an idea about continuous flow processes. Let us move on to intermittent flow processing. So intermittent flow processing, like we took the example of McD, take any other restaurant, say Saravana Bhavan, or any restaurant of your choice, Punjab Grill or something like that, right? That follows an intermittent flow processing. Why? Over there you go, the variety of food you get is much larger compared to McD or KFC or any such Burger King or any such drive-through process, right? The output variety is large. So what happens when the output variety is large? It is not that everybody might be ordering masala dosa, right? So if you go, so what happens in Saravana Bhavan, when we go, we look around, right? Is everybody ordering masala dosa? Then we'll be like, let us also order. Then we will get it fast. You remember? But in case you decide to order puri masala, then everybody else's masala dosa will come. You will sit there. Has it happened to you? It has always happened to me. So these days when I go to a restaurant, I make sure that I look around and order what everybody else is ordering so that I'll also get it fast, right? But again, some people it backfires, like me. Even if I order, everybody else's masala dosa will come, mine will be not coming. So that is the intermittent flow process. Okay, so each output will take a different route through the organization, through the restaurant, through the chefs. It uses different inputs, it requires different operations, takes a different amount of time and also sequence. So that is intermittent form of processing. Okay, so each output may be a small group of similar outputs, like there it might be a batch process or it might be customized. The main thing here is that in intermittent flow process, the outputs are varied. So each output, how input might also vary for each of these outputs. So how these inputs reach the output, the path followed might always be different between each of these outputs. So that is why we go for intermittent flow processing. So the characteristics are that it is very flexible, and what you can say, it is though it is organized around standard operations, there is still chance for customization. Material handling and in-process inventory is we try to make it as standard as possible, but it is always a little bit difficult to manage all the resources. Okay, but we can have more variety at low cost, which is an advantage. We can have high capacity utilization. Each staff will be skilled at something else, so it is much easier when you compare, to maintain that employee morale and satisfaction than a continuous flow process. But if things happen in a at high volumes, then it becomes more costly, because say if there are maybe in such a restaurant, I do not know, maybe at a time maybe they'll only have 2 or 3 masala dosa things. Okay, so that is why it happens. But if the 50 people come in and all 50 people order masala dosa, then all the other equipments that they have will not work, need not work. But this 3 masala dosa stoves, they will be totally loaded. So if there is high volumes coming in, it becomes more costly. The planning and control becomes a bit more complex, and it requires large in-process inventory, because we do not know, we have given the menu, we do not know what out of the menu the customers will be ordering. So if we have to keep up with our menu, then all the things should be available in our inventory, so that in case somebody comes and orders, we should be able to provide them. Okay, so even for intermediate flow operations, we have computer production and inventory control systems right now in place, manufacturing, resource planning, right, MRP, computer aided manufacturing, group technology and all in place to help intermittent flow processing. Now the reason why I took two restaurants as example is so that I can explain this continuous flow process and intermittent flow process to you in a much easier way so that you guys can comprehend. But this is not limited to these FMCG goods or services like restaurants. Okay, all the other products, there are variety of products, firms and places where this process can be applied. Okay, so the next topic which we will take up is the acceptance sampling. So acceptance sampling is a topic from your value engineering and quality assurance unit. Okay, so acceptance sampling comes under quality assurance. So you know how important it is to have quality checks, right? Whatever your product or service is, we need to have regular quality checks in order to maintain or ensure that the quality of our products are maintained. Because if quality is not maintained, our customers will not be satisfied with our product, we will lose our standing in the market and will end up failing, right? So quality as and assurance is very important. And how do we what you can say do this quality assurance, how do we do this QA check? Usually the what people do is, let's say if it is a manufacturing firm, let's say it is a firm manufacturing ICs. Okay, maybe which IC do you want, 555, whichever IC. Okay, some IC or some let's say motherboard or something like that, Intel's i3 chip. Okay, why not? Okay, so how do you assure quality for that particular batch of processors, or that particular generation of processors? How do you do it? What usually quality assurance team, QA team, will do is, they will it is not possible that we take up all the samples and test each sample before it goes, right? That will take a lot of time for the product to hit the market, and it will lead to a lot of time and effort being used up by the firm. That could affect our profitability also. So what usually we do is, uh, samples will be taken, right? Samples will be taken from the production, what is it, produced products or services, and looked upon for quality. So how can we take these samples? Correct. So there are many ways in which you can sample. We can use random sampling, we can use which other type of sampling, right? Lots of sampling methods we have already studied. So one such method is the acceptance sampling, which is again another statistical technique for QA. Okay, in this technique, usually it gets used where items are inspected in batches, okay, or lots. Like in this case of ICs, if you're having i3 IC, then we'll have to, let's say, if we got from the manufacturing plant, we got from the manufacturing, let's say 10,000 ICs. Okay, now with this 10,000 ICs, maybe we'll have to decide, say Samsung or any other laptop manufacturing brand, they might first get a shipment of, let's say, 10,000 ICs, i3 chips from Intel. Now using that 10,000 package, 10,000 ICs, maybe we'll have to decide whether or not should I still go and get more ICs from Intel, or should I switch to AMD or Equinox or something like that, right? So how do we do that? For that, we go for this acceptance sampling. Whether the sample they had provided us is okay, is it meeting our requirements or not, is what acceptance sampling actually tries to do. And if QA is not passed on this sample, then we will not be getting the chips from this particular manufacturer. Maybe we'll decide to switch to i5, or maybe we'll decide to switch to AMD or something like that. Okay, so what happens over here in acceptance sampling is, we will do 100% sampling of the received samples. Okay, so all these 10k chips we will subject to quality checks, and if all of them pass, or we might even set a threshold or critical acceptance level or something like that, and if it passes, then we say okay, then we can accept the product. That is what happens in acceptance sampling. So what we do is, so as I said, we will sample, or not sample, we won't sample from this sample. Okay, first of all, we are getting only a sample. Now we won't sample again further from that. We will subject the entire thing, and we will see, okay, we got n number of samples. Out of that, let's say x were defective, y the remaining, okay, n minus x were what you can say good, it passed. And depending upon that, we might plan for the further actions. Okay, so in this case of acceptance sampling, we usually what you can say, we usually prefer larger samples rather than smaller ones. Like if, say, out of this 10k, say 500 of them were defective and the remaining 9500 were good. Now if we reduce the sample size, what happens is that what if we end up having more of these defective chips in the sample? That could happen, right? So that will be detrimental to, or that will lead to wrong decisions taken. So as large a sample can be, that much good it is what acceptance sampling is all about. So the next topic was is PERT and CPM. So these both are actually planning tools. Okay, these are used for planning and control. So PERT is program evaluation and review technique. CPM is critical path method. Okay, so PERT is used actually as a planning tool to calculate the amount of time it will take to say realistically finish a project. Like for example, recently I saw a video. It is actually IT related, and it actually is true. Like for example, if it takes actually to develop a, let's say, a software, okay, software, it actually takes 3 weeks. Okay, sometimes what happens is that managers, they give just 2 weeks and all. So what happens is that is actually a very unrealistic deadline, and then they start pressuring us to give that project in that particular timeline. So that becomes detrimental. It puts a lot of pressure on the workers. It does things like that. So PERT is a technique which we use to find out actually how much time it will take, right? Sometimes what happens is that the developer might take 3 weeks, but that is after all the leaves and everything, all the leisure activities and all. So that will also not be right? So in PERT, what we do is we break down all the tasks that are required to be, completed or gone through in order to complete the task. And each of that task will be analyzed to find out the actual effort it might take to complete the task and move forward. And accordingly, we will reach at the realistic timeline that will take to finish the task. So what happens is that this using PERT, it becomes very easier for us managers to schedule our deliverables and coordinate with team members, see if there is any deviation, take necessary steps, and maintain our commitment to deliverables, right? So that is PERT. Then CPM is critical path method. So in that, what happens is that it is again a project evaluation and review technique. Okay, so in that, see, from to reach from point A to point B, there might be multiple ways, right, to reach. Now CPM tries to find out the what you can say, the most easiest, or the most not easiest, the path which we can take to reach from A to B with the least amount of resources or the least amount of inputs and complexities. So that is called this critical path method. Any other path to reach from A to B will be will be more resource intensive and time intensive than our critical path. Okay, so that is in short about CPM and PERT. This is not a new topic, especially in second semester, because we have already learned about PERT and CPM in the first semesters. Then what is material management? Material management is nothing but all the activities that are related towards the planning and controlling of all the materials or inventory, right? So it will include planning, procuring materials, evaluating your suppliers, selection of which supplier or which raw material to use, the expenditure part of it, shipping, how do we ship the materials, the receipt processes, quality control, warehousing, inventory, material distribution, all such things will come under the material management. So the primary objective of material management is to ensure that we get our materials at low prices as possible, so that our inventory is used to the maximum, procurement and processing cost is minimized, so that we can ensure there is a continuous supply of materials, consistency in the quality of the materials that we get, payroll costs should be minimum, in general costs should be less, quality should be high, that kind of a attitude or objective, that is the primary objective. Okay, and also to maintain a good relationship with our suppliers. Then new materials and products we should be able to get economically, make a good buy decision, standardization, product improvement, departmental harmony, to be able to do adequate forecasts for in order to anticipate the upcoming demand and supply fluctuations, and take necessary steps to make sure that your inventory is always having enough, not more not less, but just enough to meet your demand and supply requirements, right? So that is in short about material management. So yeah, that is it. So these are some of the topics that I got. So I hope that this video also was useful to you, and all the very best for your upcoming examinations. Until I see you in the next video, bye bye.